Hi, everybody. Alex Meller at Capnion here. Now, over the next few weeks, I'm going to talk a bit more about our software development kit, Ghost PII, why it's important, and the sorts of business problems that you might be able to profitably apply to. And we're doing this because we're going to open up some of the code to you all, the public, in a few weeks, and you can get in and tinker with these things yourself. And I'm hoping I can get you maybe excited enough with some teaser trailers over the next few weeks to do that. So, just to get started, I'm going to go into an insurance example. I'm going to build a basic model, and I'm going to do it in a way that almost everything is encrypted the whole time. And why is this important? It's just much better from a cybersecurity, data privacy standpoint if you don't have to share all this data. I'll be talking more in the coming weeks about, well, where does this really come up as an interesting pain point? But I just want to point out before I go into this example, it's very often true if you're doing data work, you're doing decision support for somebody, that person does not want to look at every row in the data. Probably even the data scientist eventually does not want to look at every row in the data. A lot of the action from a business standpoint is going to come down to something pretty compact. And so in this regression example, it's going to end up being probably you're going to end up looking at a coefficient. So you might say, what does it cost the insurance company if somebody's a smoker versus a non-smoker? That's something you could answer by looking at the value of a coefficient in a model. And then also, we love to fight about p-values forever, and we all know it's a bad idea and it leads to bad reasoning, but that's the way the world works, that the p-value is what people end up arguing about, and the p-value is, of course, just some number between 0 and 1. Okay, and so the point of Ghost PII is we're going to build this model, and we're going to get in plain text the part that's actually interesting and important in a business setting. And the trick was that the person doing the work didn't actually see any of the data prior to getting that insight. They had encrypted data, they did a magic trick on the encrypted data, and then they got out the plain text thing they needed to send to their boss. So they got their work done, but they have been eliminated as a source of risk around sharing that data. All right, let me show you the example. All right, well, what do we have here? This is, of course, a Jupyter notebook. It's a really standard Python ecosystem tool for just looking at your code running and seeing what the output is. Nothing new here. In general, at Catmion, we try to fit everything as cleanly into the open source Python ecosystem as we can, including everything I'm going to talk about is just stuff you would call from a Jupyter notebook, like you would call a scikit-learn or some other similar tool. In general, we're all about, we'd like to provide you with access to this really exciting new security technology, and we're trying really, really hard to do it in a way that it looks like things you're familiar with, and you can just get it out of the box and use it, and you don't need to know about all the fancy cryptography and these other kinds of grisly details. So if some of this looks familiar, like stuff you're already doing, yeah, that's absolutely the intent, and we're trying really hard to take care of you. All right, so what's happening here? How does it work? So first I'm going to scroll down a little. We have a data set. This is putatively information about customers of an insurance company, and we want to take this information. This is standard actuarial stuff like age, sex, are you a smoker, what's your BMI, and then we want to model what did it cost this person, what kind of claims did they file, what did it cost the insurance company to have them as a customer. This kind of data can be pretty sensitive. You don't want to lose it for a wide variety of reasons, and if you want to analyze it, you got to give it to a bunch of other people, potentially put it on a bunch of other computers in order to get the analysis done, at least until now. So the whole point of what we're doing here is we're going to encrypt this data. That's what's going to happen in this step right here. And it's a little more complicated than this, but now underlying that object is a bunch of ciphertext, which is, in this case, just a bunch of crazy, huge numbers that, in a particular sense, are really hard to reverse engineer and find out the sensitive data. But then down here, we're going to do regular old linear regression and build a model predicting those charges right here. This is our outcome variable using the other columns in that data set. And we're going to imagine, we just want the coefficients. We don't really care about the underlying data that much, except to the extent that it affects the coefficients. And coefficients are really going to what's going to drive business interest, if a high coefficient comes out of this model that's saying that that variable predicts that that person's going to charge the insurance company a lot of money, and that's what we're interested in here. And the whole outcome, in a way, is very boring. You could have done this in the same way on the plain text with scikit-learn, and using Ghost PII on the encrypted data, you get exactly those same numbers up to some significant figures. So we performed this task analyzing the data, computing this regression model. We did it on this encrypted data. In another scenario, maybe we would be passing this encrypted data to another person. We no longer had to pick up the extra risk of doing that or reveal anything private about anybody. We could get to where we wanted to go without some of the dicier steps in between. I just want to add that this magic trick here is maybe even a little bit more radical than it appears, in that we are absolutely not decrypting in some special hidden way or in some secure enclave like that and doing the computation as scikit-learn would do it. This is a special computation that you do directly on the cryptography. So everything up until that plain text coefficient number was encrypted. And if you somehow snuck in into the middle while the library was computing to try and learn something interesting, there would be nothing prior to that coefficient in plain text. Just the part you need at the end for whatever your business goal is something you can have be in plain text and absolutely nothing else. So I got more magic tricks like this. We're going to have little mini-series over the next few weeks, talk about some other kinds of models, do some basic data wrangling, these kinds of things. Get into some of the business reasons why you might find this especially important or life-saving in certain situations.